In this video, I want to talk about the fundamental theorem of calculus. There are two parts of this theorem, and I want to talk about the part 1 now. There's a function f, which is continuous function on a to b, and there's a function g of x, which is defined by this function, and the x is from a to b. And g is also continuous on this interval and differentiable on this interval. Then the g prime of x is equal to d dx integral a to x and ft dt is equal to f of x. Therefore, this g prime of x is equal to f of x. This is the first part of the fundamental theorem of calculus. From the formal definition of the first fundamental theorem of calculus, we got this function. But what we have to notice is that the boundary is not from a to b, but is from a to x. Why this happens? To explain this, I'll have to draw a graph that represents this function visually. Well, let's draw a graph. This axis is t and y. And there's a curve that is defined as y equals f of t. And therefore, the area under this curve must be gx. And there's a point between a to b, x. So therefore, the g of x, which represents the area under the f of t, so the boundary must be from a to x, not from a to b. From this, we can see that f of t is differentiable and continuous on the interval from a to b. But what we also have to know is that g of x also must be continuous and differentiable on interval a to b. I'll explain you why. So f of t is derivative of g of x, and g of x is anti-derivative of f of t. And f of t is differentiable and continuous on interval from a to b. Now, you have to get the f of t when you get the derivative of g of x. In order for this situation to happen, g of x also must be differentiable and continuous on this interval. Therefore, g of x also must be continuous and differentiable on interval from a to b. And from this graph, we can find the relationship between derivatives and integrals. So, there's a function f of t, and when we integrate this function, we get the area, the accumulation of this function. And if we get the derivative of that area function, we get the curve. So this is the relationship between derivative and integrals that can be represented visually. So far, we have learned about the definition of fundamental theorem of calculus. Let's solve the question using this theorem. Here we have f of x, which is defined as integral negative 4 to x t minus 1 dt. Then what would be the f prime of x? From the definition, we know that if there's a gx, then an f t. This is an integral from a to x. Then the g prime of x is equal to f of x. Therefore, from this question, the only thing we have to do is to replace this function and the t inside with x here. So f prime of x is equal to x minus 1. We solved this using the fundamental theorem of calculus. Let's move on to the next question. Here we have this function. It looks pretty similar to the previous one, but there's some difference, and that is the boundary is variable here from x to the x squared. So therefore, what we have to do here is to separate this function into two parts. Let's do this. From x to 0 to t squared minus 8t plus 11 dt plus from 0 to x squared t squared minus 8t plus 11 dt. So we're moving from 0 to 11, so we have to change the boundary by multiplying negative sign in it. Here, this part's it's the same. So we can easily solve this problem using the fundamental theorem of calculus. Just as before, for these parts, we can simply replace the t here with x here. That is x squared minus 8x plus 11. But we have negative sign here, so we have to multiply them by negative sign. And simply here, it's the same. Let's do this. So is x to the 4th power minus 8x squared plus 11. But there's one more step we have to do, and that is to multiply this function with the derivative of this boundary. The derivative of x squared is 2x, so we can multiply by 2x. Let's simplify this function. So, yep, this part is multiplied by negative sign, so it's negative x squared plus 8x minus 11 plus we have to multiply by 2x, so 2x to the 5th power minus 16x to the 3rd power plus 22x. So we can add this. The answer is 5 to the 3rd power minus x squared, and we have to add this, and that is 30x minus 11. So this is the final answer. We can solve these questions by using the fundamental theorem of calculus. At the beginning of the video, I mentioned that there are two parts of the fundamental theorem of calculus, and now we are going to learn about the second part of this fundamental theorem of calculus. This theorem states that if there's a function f which is continuous on the interval from a to b, then the integral from a to b of f of x dx is equal to capital F of B minus capital F of A. Then what is the difference between capital F and just small f? Let's see here. The capital F is an antiderivative of small f. So naturally, the capital F prime should be the small f. This is the formal definition of the second fundamental theorem of calculus. I explained the fundamental theorem of calculus verbally, but I guess this is not that efficient to convey the full concept of this theorem, so I'll explain you this theorem visually. So there's a x and y, and there's a function, let's say f of x, f of x. And we want to find the area under the curve from A to B. And the area function is the antiderivative of small f of x. So therefore, the function that is for the area is the capital F of x. So mathematically, we can represent this situation into this. But we have the interval from A to B. So simply we can add this A and B here. So that is equal, again, f of B minus f of A. So to find the area under the curve from A to B, we can get the antiderivative of small f of x and plug the B and A and get the difference of the two values. So we can find the area under the curve from A to B. This is how the second fundamental theorem of calculus is represented visually. So far, we have learned what the second fundamental theorem of calculus. Then let's solve the question. Here we have this integral function. To solve this problem, the first thing we have to do is to take the antiderivative of this function. And by using the power rule, the antiderivative is x. And this is f of x, capital F of x, because this is small f of x. And from the definition, to find the area between this interval from 0 to 3, we have to subtract f of 0 from f of 3. So the only thing left is to simply plug this number 3 and 0 in this function. So let's plug this out. This is equal to negative 81 over 4 plus 27 minus 6. And this is again equal to negative 81 over 4 plus 108 over 4 minus 24 over 4. And this is equal to 3 over 4. So the next step is to subtract 0 from this number, and the answer is 3 over 4. So the answer is 3 over 4. So let's go to the next question. Here we have this function, and just as before, the first step we have to do is to find the antiderivative of this function. And how do you do this? We can use u substitution. And the u is equal to 2x plus 4. So du is equal to 2 dx. And we have 2 dx here, so we can substitute this values with the du. U cube. So this is equal to u to the negative third power. This is again equal to negative 2 from negative 1 to 2. So how do you do this? We can resubstitute this u with 2x4. So this is equal to 2x plus 4 squared. So the next step is to plug this number into this function. Let's do this. 4 plus 4 squared minus negative 1 over 2. Negative 2 because we're multiplying with the negative 1 squared. So what's this? This is 8, and if we square this, then we get 64. And this is negative negative, so this is plus. This becomes 2. 2 squared is 4. 4. Again, this is then equal to 1 over 128 plus 1 over 8. And this is again is 16 over 128. And this is equal to 15 over 128. So this is the answer. So the area under this function from negative 1 to 2 is equal to 15 over 128.